All right, how you guys doing? My name is Darius Pandy. Some of you guys may know me as the math guy. But anyway, what I'm going to do is I'm going to solve this problem that's on this board. Some of you guys have already seen it already. I've already posted earlier. So we're going to solve it. It is a equals 2 divided by the quantity of log base 11 of 385 plus 2 divided by the quantity of log base 7 of 385 plus 2 divided by log base 5 of 385. Now, the thing about this equation is that we have to solve for a, okay? So we have, well, what I'm going to do is I'm going to show you two different formulas that we can use to actually solve our problem to where it can be such an easy answer. The answer is going to be 2, and I'm just going to show you the reason why it is, okay? So the two forms we're going to use, okay? One of them is going to be what is called the change of base law. And so what that says is that if I have the, let's say I have log base of a of b. If I want to change the actual base of it, okay, what I could do is I can have it be log base, let's say c of b divided by log base c of my original base, which is a. Okay, so this is what I'm going to have. I'm going to write that as that. Okay, so that's going to be one of the formulas that I'm going to use. The other one that I'm going to use is going to be where the argument and the actual base is the actual same value, and that equals 1. So what I'm saying is that if I have log base of r, that just equals 1, okay? And you're going to see how I'm going to use that later on at the very end, but you'll see how it's going to be something simple, okay? So here we go. So going back, let me just rewrite the original equation, which is this one. Okay, I'm going to rewrite that over again. So we have a equals 2 log base, what was that? Was that 11, the first one? Yes, it was 11. 11 of 385 plus 2 over log base of 7 of 385 plus 2 over log base of 5 of 385. Okay. So remember, again, we got to solve for a. All right. We want to make all of the log bases, the 11, the 7, and 5, the same number. Okay. You can choose any number that you want to choose. What I'm going to do is I'm going to choose everything to be log base 5. And I'm only doing it because I just want to choose 5. I could have chose 7. I could have chose 11 too as well, but I'm just going to choose 5 for now. Okay. So using that with the change of base law, so I'm going to make this part right here. It is now going to be 2 over, I'm writing this in a different color. Let's choose red again. So I'm going to say instead of being log base 11 of 385, it's going to be log base 5 of 385 divided by log base of 5 of my original base, which was 11. Okay. And then that plus 2 over log base 5 of 385 divided by log base 5 of my original base, which was 7. Okay. And then in this one, I already have a log base of 5 of 385, so I'm going to leave that one just how it is. So it's going to be 2 over log base of 5 of 380. Okay. All right, so that's what I have so far. Now, with these fractions right here, what I can do, according to my fraction rule, is that since I have a fraction in my denominator, I can bring this part of the fraction, the denominator of the denominator, I can bring that part up to my numerator right up here, and the same thing I can do with that one too as well. So I'm going to write this as 2 times log base of 5 of 11 over log of 5 of 385 plus 2 of log base 7, log base 5 of 7 over log of 5 of 385. And then, like I said, this one stays the same, plus 2 over log base 5 of 385. Okay. So now that I have that, what I'm going to do now is that since I have all of these same things as the denominator, I can just multiply my denominators and put those on the other side of this equal sign, which is where a is at. So I now have a times log base of 5 of 385. Okay. Equals, I have a 2 here, a 2 here, and a 2 there, so I can factor the 2 out. And I'm left with just the log base 5 of 11 plus log base 5 of 7, okay, plus 1. All right. So now that I have that, according to my logarithm laws right here, I can add these two things together. Well, when I have two logs that have the same base but they're being added, it's the same thing as multiplying. Okay. So this now becomes instead of it being 11 plus 7, it's going to be log base 5 of 11 times 7, which is 77. And then I still have my plus 1 here. Okay. All right. We're almost done. Okay. Hope you guys are following along pretty good. If you are confused, just pause it, go back, and then, come back with it. All right. So now that we have that, I'm going to take my 2. Okay. I'm going to divide 2 on both sides. So I can get rid of the 2 over there. So that crosses out. So now I have a over 2 log base 5 of 385 equals to log base 5 of 77 plus 1. Now, I'm almost done. And this is the part where some people may get stuck at, because you can actually go ahead on and try to solve it from here. But the thing is that the thing that's blocking you is this 1 right here. Okay. So remember earlier when I told you about this formula right here, this is what I'm going to substitute. Okay. So 1 is the same thing as saying log base of r of the same argument of r. So I'm going to change that 1, because since I have my basis as 5, I'm going to change that to being log base 5 of 5. It's the same thing. Okay. Now that I know that, I have another logarithm thing where I have, this is supposed to be a 5 right here. Sorry about that. Again, how I combine the D7 and the 11, I'm going to now combine the 77 and the 5. And guess what that's going to equal? 77 times 5 is 385. So I have log base 5 of 385. And then to finish this off, I can divide both sides by log of 5 of 385. And that cancels out, that gives me 1. So a over 2 equals 1, which means that a equals 2. Thank you.